let's consider this question on board on chemical reaction. Now, a graph as this is given. The question is, what is the activation energy of the backward reaction in the diagram above? There are two questions here. The second one is, what type of chemical reaction graph is represented what above? Now, we are asked to find the activation energy of the backward reaction of the graph above. These are the values, the energy values, the graduation of the graph, showing the reaction coordinates. We have 100, 200, 400, 500, what to 600. Now 600 is what is the highest point. Now, for you to understand what type of graph is given or what type of chemical equation is represented here, you must go to the question. You must look at the activation energy. What is the activation energy of the backward reaction? You go by, you think back. What type of graph? What type of chemical equation? We have different types of chemical equation. What type of chemical equation has the word activation energy? Now, what is activation energy? First of all, activation energy is the minimum amount of energy that is required for a chemical reaction to take place. Now, there's a particular graph or there's a particular reaction that talks about activation energy, and that brings us to endothermic or exothermic reaction. It brings us to what? Endothermic or exothermic reaction. Exothermic reaction. Now, it is these two types of reaction that talks about activation energy. Let's underline activation energy. I've said that it is the minimum amount of energy required for a chemical equation to take place. Now, they said, what is the activation energy of the backward reaction in the diagram above? Now, in this diagram, this is the reactant. This point is called the reactant. Here is called the reactant. Here is called the product. Now, for a product to be formed in every chemical reaction, time will be taken. This is the reaction coordinate. It moves this point to the highest point. Then the product is formed at this point. Now, the highest point here in this graph is called activation complex. It's called activation complex. That is the highest point. That is the point at which the reaction occurs. The highest point in which the reaction occurs for the product to be formed from the reactant. Now, the question is talking about the backward reaction. There's a formula for calculating backward and forward reaction. For the backward reaction, let's take it in two ways. First equation and second equation. This is activation energy is equal to energy of the activation complex minus energy of the reactant. This is equation 1. Then we have activation energy is also equal to this for forward reaction. This for forward reaction. Then this is for the backward reaction. Activation energy is equal to what? Energy of the activation complex minus energy of the product. This is equation 2. Now we are going to use energy. We are going to use equation 2. That is, activation energy is equal to what? Energy of the activation complex, that is AC, minus energy of the product, that is equation 2, to calculate for the backward reaction. But before we calculate the backward reaction, we'll also consider the forward reaction so that we'll get our point. Now, for the forward reaction, in any endothermic reaction graph pathway, EA is talking about the activation energy, which is equal to EAC, activation complex. Now, if you look at the graph, the highest point in which the reaction takes place is 600, which is the activation complex. Now, for we to calculate for the forward reaction first, we'll say 600, which is the highest point, the activation complex, 600 minus the energy of the reactant. Now, the energy of the reactant is the point in which the reaction started, which is 100. Now, 600 minus 100, which is the energy of the reaction, minus 100, we have 500 kilojoules. This is for the forward reaction. But in this case, we are asked to calculate for the what? For the backward reaction. Now, the backward reaction here, the backward reaction, we have 2xy, which still give us x2 plus y2. x2 plus y2 for the backward reaction. 2xy will still give us x2 plus y2 for the backward reaction. So applying this formula, EA equal to energy of activation complex minus energy of product. Now you will trace the point at which the product was formed. At what energy level is the product formed? We'll give me this dot. We'll give me the dot. We'll trace back. Now, if you look at it from the tracing, the product is formed at 200. The product is formed what? At 200. Now, the highest point is 600, which is the activation complex. So for the backward reaction, you say 600 minus 200, where the product is formed. EP means energy of activation, energy of the product. EP here is what? Is 200. So which is equal to what? To 400 kilojoules. So from the question now, the activation energy of the backward reaction is in the diagram above is 400 kilojoules. For the forward reaction is 500 kilojoules. So from this now, the energy, the activation energy for the backward reaction is 600, the highest point, which is the activation complex, minus 200, the energy of the product, where the product is formed. This is the tracing. The product is formed at 200, based on the slope of the graph. We have now 600 minus 200, 600, which is the activation complex, minus the energy of the product, is 400. So for this question, the activation energy of the backward reaction is 400 kilojoules. Now, number 2, what type of chemical equation, what type of chemical reaction graph is represented what above? Now, the type of chemical reaction graph that is represented above is endothermic reaction. Is what? Endothermic reaction. What is endothermic reaction? It's a reaction in which heat is being absorbed or heat is gained into the reacting system from the surrounding. That is what we call endothermic reaction. Now, and that is why if you also look at the graph, the product is higher than what? The reactant. The product is higher than the reactant. In the movement of the graph, the product is higher than the reactant. Now, also, because heat is being absorbed into the reacting system, delta H, change in heat, delta H change in heat is positive in endothermic reaction. But if we are talking about exothermic reaction, since heat is given off to the surrounding, delta H becomes negative. Delta H becomes what? Negative. Delta H means change in heat. Change in heat. So at this point, I believe we have gotten what we actually put on the board.